I'm presenting on my research, my chemistry research that I did over the summer, in the fall, and the spring. So my research focuses on this molecule called Tröger's base. It was founded in 1887, and the really neat thing about this molecule is that it has a 90-degree angle. So it's between 85 and 100 degrees. But the really neat thing is that this molecule, because it has this straight corner, just like Legos and building blocks, we can build one molecule on top of the other. So this is great because it can serve as a nanometer-sized building block. And what we did is by changing the methyl group on the sides of Tröger's base, we can make different substituents. So we can add on over here, you can see an oxygen, and we can make a Tröger's base with a dimethoxy group on the top and on the bottom. So we did this with different molecules of Tröger's base to make different derivatives. So over here you have a tetramethyl, so 4 methyl groups, and then you have a di-T-butyl and dichloro. So what we did is we found this other molecule that we tried to add on a difluoronyl substituent, and you can see that 3 different products were observed. But because of steric hindrance, which is basically just too many things in one place, only one product is the major product, so we see this one most often. But one of the cool things about Tröger's base is that it has 2 different isomers. So in case you don't know, isomers, just like your hands, are mirror images of one another. So they might seem exactly the same, but you can't place them on top of one another because they are different. So what we did is we have a racemic mixture, a 50-50 combination of these 2 isomers, and in order to separate them, you add acid and you make this complex. It's a salt. And if you have this solid salt, you can filter out the other isomer. So you're left with just either the RR or the SS. And to make sure that we only have this one isomer, we run an HPLC, which is basically just column chromatography. And so you can see the black is over here and the black is also over here, showing that we have a 50-50 mixture, some of one isomer and some of the other. And after we made the salt complex, we only had a little bit of the first isomer and much more of the second. So this is for the dimethyl, and then over here we have the dichloro, which was completely successful. We only have the blue, 100% of this one isomer. So we can prove that our research was correct.